First and foremost, with this, our given here, we have our interval and frequencies. You notice we are talking or dealing here with group distribution. So we are going to find now or solve for the variability, specifically variance and standard deviation for group distribution. Okay, that this is for the variance. What about standard deviation? Okay, I'll just use with S or I'll just use S here because in most textbook that I'm using, the psychology book, they use S only. But the SD and S, I am referring to the same measurement, which is standard deviation. Because there are also other books in general mathematics, they will use SD to represent standard deviation. Okay, but do not be confused. S and SD, I'm only referring to standard deviation. Now, we have already this formula here stated, and this is our given. Now, from here, where do we go next? What will be the next thing that we have to do? Okay, which is represented by X sub M. So we have 1 plus 7 divided by 2, that is 4. And now, to complete this part without actually doing the same process over again, we just simply get or have our I added to the first midpoint or the previous midpoint. But before that, what is our I in this distribution? Okay, our I is 7. What is the summation of F here? Okay, that's 20. This is our N, which is the summation of the frequency. We have already our I, and let's continue having our midpoint. 4, 11, then 25, and then 32, 39. Okay, so we have now our N3, which is the midpoint. Okay, we will find the product of our midpoint and then the frequency. Okay, we have already this column completed. Now, of course, we need its summation. For this column, the summation of Fx sub m. What's the summation for this column, Apelyedo? We're back. And we're waiting for Apelyedo to provide us this one. What else needed? Navarro.
Sorry, plus and answer.
Yeah, Apelyedo, I'm asking you what's the summation of this. And then Navarro, I'm asking as to what will be the next column. Apelyedo, we're still waiting for the summation. And then Franga, what is the next column?
Sir, 437, sir.
This is 437.
37.
Okay, that's 437. That's the summation. I'll go back to Franga. What is the next column after this, the product of Fx? Bilingan.
XM squared, sir.
But we don't have yet x squared. First is we need to get F, the square of the midpoint. Can you please help me, Bilingan, to fill in this column? What is F? Let's complete the Fx square, Fx sub m squared. X sub m squared, that is the square of the midpoint.
Okay. Okay, sir. 16, sir.
Okay.
And 1 to 1. 1 to 1. 324. 625.
What else?
1024 and 1521.
Okay, we have already this column. The next column is of course the product of the frequency and the squared midpoint.
16.
Next.
1,089. 11,664. 625, sir.
Sir, I think it's 1,944.
Whether this is correct. That's 1,944. What about the
answer, sir? Mabaw. 363.
That's 121 times 3. 336, 363. The meaning of this one, this is frequency times the squared midpoint. So that's 1 times 16. That's why you have 16. 3 times 33 is 363. 6 times 108, that's why this is the answer. Continue. 3,125. Next.
4,096.
Last.
1,524.
21. This is 21. That's 11,065. So we have this already. Substitute in our formula. What is our S squared? Our summation of the product of frequency and the squared midpoint is 11,065 minus the summation of the square root of the summation fx sub m, which is 43,437 square divided by 20 divided by 20 minus 1. Oh, give me the answer for the standard, the variance.
79.82, sir.
Okay, we round it to the nearest hundred. We have 79.82.
82.
Now, what is our standard deviation? Okay, we have 8.93. So we have now our variance, and then we have our, this is our variance S squared, and then our standard deviation is 8.93. So that is already, this is one of the method in how we will find the variance and standard deviation of this distribution. But before that, I would like to ask, what is the mean of this distribution? Why don't you start giving us the formula of the mean and then you give us the mean of this distribution? Okay, that is 21.85. It's because our summation of n here, or f here, it's the summation of fx sub m, which is 437, which is divided by n. That's 437 divided by 20, so we have 21.85. This is our mean. Now, what is the meaning of standard deviation? I'll just quickly introduce to you how do we interpret this one. Now, this is our mean, which is relatively, if we're going to look at in our interval, where do you think we will find or locate this mean value in our distribution? Or at least in our interval, because our score were now grouped. Where can we locate this? 21.85 is indeed here, but your explanation does not suffice why it's found here. Remember, if you can recall our class boundary, the boundary of this one is 14.5 to 21.5. That is the real limit. And then this one is 21.5 to 28.5. When you have 21.85, that's within this interval because this one was in the 21.5 until 28.5 as its real boundary. And thus 21.85 is within this interval. So guaranteed now that our mean is found in this interval, that is in the fourth class interval. Well, basically, if you were going to look at this one, it will also somehow explain to us that this is found in here. But there is a better way of explaining why our mean is found in this interval using our real limit or the class boundaries. Okay? So we have this one. Why did I brought this idea? Before we'll proceed, I'll just quickly relate now what's the purpose of finding the mean in relation to our mean, finding the standard deviation in relation to our mean. It's like this. In a group distribution, we locate the center, which is the mean. Now, each of the score will be transmuted, or I should say, you're going to transform it in terms of z-score, which will be our next lesson. I'll just introduce this very quickly, that the z-score now, each score in your distribution has a corresponding z-score value. Z-score is now going to represent that particular actual score. Example, in this distribution, the actual score, if you have 21, that actual score, 21, will be converted into its equivalent z-score. And that z-score now will help you identify through that z-score, which is equivalent to 21, will tell you how many standard deviation is this score 21 is away from the mean using the z-score value. Now, if, for example, 21 is one standard deviation away from the mean as it was transmuted using z-score value, it will tell you now that one standard deviation is equivalent to 8.93. Okay? So it's like this. Again, I'll repeat the process, or I'll repeat how we're going to interpret it. In your distribution, we have the mean, we have the standard deviation. Now, what we will do with that to identify that, as you locate the focal or the center of your distribution, which is the mean, each of the score around the mean will be converted into z-score value. Z-score is a score that is transmuted in terms of standard deviation. So that when you have, for example, you have a score of 21, you will know how many standard deviation is 21 away from 21.85 as the mean. So that if you will say, for example, 21 is converted to z-score, the result is um, 1. For example, -1, because this is less than 21, is less than 21.85. So let's say the equivalent z-score for 21 is past -1. It means to say now that the score 21 is one standard deviation below the mean. That's why it's called -1, which means that that is equivalent to 8.93, whatever is the unit that we're talking about for that distribution. Okay, that's how we relate now standard deviation and then the mean. Question. Well, anyway, we will have a thorough discussion of this one when we talk about z-score value. But that's it. I'll just park it until this far, guaranteeing you that that's the one of the purposes as we try to relate now standard deviation to the mean as its purpose. Okay? I suppose there is no more question. We're good with this one. But there is another though, there is another formula to solve for the mean and standard, to solve for the variance and standard deviations for group distribution aside from this one. And group data distribution, there is two computation for the variability also. The same also is true for group distribution. There is also another method. Now, this method that I will be introducing is very helpful for us in locating our kurtosis or quantifying the kurtosis and the skewness of our distribution. Okay? So, let's go to that formula. Now, let's see whether we will arrive with the same answer using the second formula that I'll be introducing. First is, I think we will just remove this one. We don't need these columns. What we need here is we need column for individual score minus the mean. Remember this one, we have this column also when we computed the other formula last time. But this time, instead of using x here, we use the midpoint, the representation for each interval. So we have now the difference of each midpoint and the mean of the distribution. Ali,
1.15.
remember it is the midpoint minus the mean. Our midpoint is 4, our mean is 21.85. Your answer seems so far.
Sir, is it negative 17.85?
Negative 17.85.
17.85.
Next,
Negative.
-10.85, sir. -10.85.
Negative 3.85.
3.15.
10.15.
17.
72.
If you try to add this all together, what will be the result? Because in our ungroup distribution, once you add this column, the result is 0. I don't know now this time if it is still 0. The answer is not 0, but negative 2.5, 2.1. There is no way for us to solve for spread the data because we're now talking about there's no such thing as spread of data that is in negative form. Okay? So we need to remove the negative value here by means of squaring it. So we will get now x sub m minus the mean square. Okay, to get rid of the negative values. This time we will round our answer to the nearest hundreds for convenience sake. We have the mean minus the square of the square deviation of each midpoint.
318.62.
Next.
117.72.
72.
72, sir.
Wait, these are all negative, positive.
All positive na, sir, kay squared man.
Very good. Next.
14.82.
Next.
9.92.
Next column.
103.02.
103.02. Next.
And 294.12.
I hope others, you also have this value. I mean, this value are all correct. Next column that we need is we multiply the frequency and the square deviation of each score or each midpoint away from the mean. So we have f x sub m minus bar raised to 2.
18.62.
318.62 next.
353.16. 88.92. 49.6. 515.1.
294.12.
12.
Others, those who are seeing this one, are this all entry correct? Can you double check? Now we will get the summation of this column. We have the summation of f x sub m minus bar squared. What's the summation? 412.08. Okay, get the total now.
1,516.5, sir.
1,516.5.
0.5.
Now let us solve the value for this one. Let's solve our variance. That is s squared equals the summation of f x sub m minus this one squared divided by n minus 1. And what is our standard deviation? Still, we arrive with the same answer using this formula. So either method, we are still going to arrive with the same value. But why do we need this one? Because if we're going to solve for the skewness and then the kurtosis, we quantify the skewness and the kurtosis of our distribution. This is somehow our path in doing it. Before that, I would like to know what is the purpose or what is the meaning of kurtosis, I mean skewness. What is the purpose of skewness?
To measure, sir, the symmetry of probability distribution of real valued random variable about its mean.
Explain it using your own understanding or how you understood the concept. In short, skewness is used to measure, as it mentioned, the symmetry of the distribution clustered around the mean. It's basically, we're trying to look at the tail of the distribution, whether we have a normal distribution, whether there is a longer tail on the right side or the left side of the distribution. When there is a longer tail on the distribution to the right, that is skewed to the right, meaning to say positively skewed, there are more entries or there is an extreme value quite far away from the rest in the above the mean, and then if negative, there is an extreme value that is found below the mean. Okay, and basically it will help us describe whether the distribution is normal or not. As we know that when the skewness of the distribution is 0, it's we have symmetrical or identical tail, both right and left side of our distribution. But if our distribution is -1 above, -1 or less, it means to say that our distribution is negatively skewed. There is longer tail in our, if you try to remember the graph, there is a longer tail in the left side. But if our skewness is positive, there is a longer tail in the positive side. If you take note with the graph, there is a longer tail of our distribution in the right side. Okay, so that is for skewness. Now, how do we solve skewness of our distribution? For group distribution like this, we have the same formula, but this time we are going to use frequency and midpoint. As much as we use frequency and midpoint also in identifying the variance and standard deviation. What we need here is we need column f x sub m minus the mean to the power of 3. Meaning to say, we multiply frequency and then the cube deviation. This is the square deviation, which is the difference of each midpoint and then the mean. But this time, we're looking for the cube deviation. So we will raise now the deviation of our midpoint away from the mean 3 times, or appears as a factor 3 times.
Negative 5,687.41, sir.
Negative 5,000.
Okay, no, wait lang. Negative 5,687.41.
Negative 3,831.87.
Okay, there you go. 808.87. Next entry.
342.40, sir.
This is still negative. Yes, this is already positive.
156.28, sir.
Okay, that's 156.28.
4,182.71.
4,182.71.
5,044.20.
Okay, I need the summation for this. That is negative 478.49. In this case, you see that the distribution is negatively skewed. So let us solve now our skewness. We have skewness equals the summation of f times midpoint minus mean to the power of 3 divided by n minus 1 times s to the power of 3. Negative 0.04. So you notice this is our skewness. Negative 0.04. It's negatively skewed but almost 0. So as you notice, if we try to somehow look at this distribution in terms of its skewness, it's almost normal. Because you notice our value is negative 0.04. It's almost 0. But still, we cannot disregard the fact that there is still a decimal point of 0.04 and it's negative. That's why we can still conclude that this distribution is negatively skewed, although it's almost normal. Okay? Any question on how we solve for the skewness of our distribution for group data set? So basically, everything are just the same, but this time we computed it in terms of the frequency times the cube deviation of each score or each midpoint away from the mean. Okay, so that is negative 0.04, the value of our skewness. Any question?
Kanang dili na day necessary kuhaon ang kanang xm minus mean, like ang cube sa xm minus mean, sir. Like there should I times sa frequency.
Actually, what I did in the calculator is, example, this one, negative 17.5. What I did is negative 17.5 cube times 1. That's why I will get this answer.
Sir,
Of course, I still have to get the qubit, but I did not show it anymore here because I only have limited space.
if kuhaon nimo daan ang cube lang, sir, like wala pa nimo hilabtan sa frequency kay kanang ima-round off na magdiretso ang decimal, sir. So like if i-times na nimo sa frequency kay lahi na ako result, mo ko buhat mo to manalibog ko. Negative
Then you
17
rounded the value already.
Oo, giround na daan ang value, sir. So igbutang sa frequency, sir. Ig-multiply nimo sa frequency kay mulahi na ang answer, sir. Like sa decimal, lahi na ang decimal nimo na value. So dili
It's
na
still the
necessary, sir, nga butang. Oh, sir,
still the same.
negative 17.85 nya ang second lang nga column, sir, kay 1 ra man gud ang frequency sa kuan. So same ra jud ang value. So ang second column, sir, is
Yeah, actually,
negative
try this second column, the second row.
Oh, sir, negative 10.85 niya imong i-cube. Ang result is 1,277.29. 0.29 na kagi-round off naman nimo. So 1,277.29 niya
Times
i-multiply
3.
nimo sa frequency na 3. Niya imong answer, sir, is 3,831.87. Aw, ay saha, ang kanilang ko answer, ang lahi, sir, ang nasa last, sir.
The still one.
Ay, joke. Let's try the second to the last column, sir. 1, 2, 3, 4. The fifth, sir. Let's try, guys, sir.
Just the
Ang
decimal
value
point
sa
here.
decimal, sir.
There is just a few minimal, but still, as I understand, we will still arrive or get the same skewness. So we will have to agree now. Whether we squared it right away or you wanted to separately do it, because definitely what is allowed here is we don't round the values as often as we can. We normally try to minimize rounding of values as possible. It's because it's going to change the result.
Yes, sir.
This is happening to us because we're doing it manually. But if we're doing it actually using software or else, this is never a concern to us because automatically what will be provided for us is the final answer. Now, just to settle that concern here, because someone is raising that the result here somehow the decimal point changes, although I know the changes here did not change or will not change so much of our skewness, but for at least to settle that one, I would appreciate if we will just right away do it this what we did right now, just to minimize the columns that is needed.
Okay, sir.
So what you need to do is, and then we minimize we round value to the nearest hundreds one time. I mean during the after we multiply with the frequency already. So what I'm saying here is that you cube first this one, then multiply the frequency, then whatever is the result, round to the nearest hundreds.
Diretso
Okay?
na, sir. Dili na day ka mag-make og column na kuan pa nimo daan, i-cube
Yeah,
daan.
because I'm trying to minimize here the time of, coming up with several columns. I would rather say that we will just cube it in the calculator, multiply the frequency, and whatever is available, round it to the nearest hundreds, then write your answer in this column. So we can skip one more column in our table. Because just
Okay,
imagine
sir.
that you have all the columns starting from mean, median, mode until kurtosis. I'm not sure how many columns do we need to comply. Just to, if we're going to do it one at a time. If there is a means that we can cut one more column, then let's do it. And this time we'll cut the column, this column intended, but automatically we multiply it this way, considering that we know this is our target or intended value needed. And then what you're going to do is once you have the value for this one, you just that's the time round it to the nearest hundreds. So again, we will cube this column, cube this one, and then we'll multiply the frequency, and whatever answer we will get, we'll round it to the nearest hundreds if needed. While we're having only this difficulty, it's because of our our mean value, which is in decimal. Okay, so that's actually the catch when we're dealing with the median, mean that is in decimal form. But if our mean is whole number, I know this is never gonna be a problem. But just to be consistent, and then everybody, we're going to do exactly, we will solve it all together the same way. So just follow what I did or what we did earlier. We will get the square of the cube of the midpoint deviation multiplied to the frequency, then whatever is your result, that's the time we round it to the nearest hundreds if needed. Okay, I said if needed, it's because if the answer is whole number, then of course there's no need for you to round off your answer to the nearest hundreds. But yes, thank you for that keen observation. What I instructed you last time was that in your value for the mean x minus mean cube or to the power of 4 or squared, round it to the nearest hundreds. I think there's no problem there. It's because we don't have f there in the picture. What we just have is just the score minus the mean. Now, as we get the square deviation, we round it to the nearest hundreds for convenience because I instructed it in the question itself. Although I said that we only round up or we're only tolerating rounding of values to the nearest hundreds in the final answer, that is to minimize getting an answer that's very far away from what's the actual. But in that case, I made it clear that we only round up the nearest hundreds in the table because for convenience, because if I'm not mistaken, it would entail like 4 decimal places once you compute the x minus x bar.
Sir, na mag-aas lang ta ko, sir, ba, if wala mo guna ko na klaro ganina kaya kung connection nawala. Ang kanang sa formula sa skewness, sir, ba, sa ubos, sir, kanang n minus 1 and then S3. Diyon sa galing na, sir. Ang n, diyon sa galing na, sir. So, 20 minus 1.
19 times 8.93 to the power of 3. Now, in this case here, you cube first before you multiply. Do not make it 19 times 8.93 and raised to the power of 3 because that's another story. This is where you need to apply PEMDAS rule. Exponent first before multiplication. Okay, now we did already our skewness. Let's have our kurtosis. So this time, I'm going to erase this one. I'm going to replace this by 4, and then we will erase the entry. That is now us solving for the kurtosis. So I need now a volunteer to help me solve this column. Well, we will just exactly do the same process with what we did in our skewness. 101,500.
20, 520.29, 41,575.76,
1,318.24,
ay 492.28,
42,454.54.
86,500.05.
Sir,
Yes.
ang kanang first column sa to the power of 4 kay kanang 101,520.29 dili na siya i-round off. So dili na siya 0.30.
It's actually 0.30.
Okay, sir.
That's why actually I have it already here. So 101,520.3. 0.3 or 0.30 is the same. Okay, so our kurtosis is 2.27. So that is how we quantify, or this is at least the value of the curve, the peakness of our curve for this distribution. So we have 2.27. So we completed already our variance, standard deviation for two formulas of group distribution. Together, we solve also the skewness and the kurtosis of our distribution.